Hello everyone and welcome to our first webinar of the GLP working group on telecoupling for the transformation of land systems. My name is Cecilie Zaehringer. I'm a researcher at the Center for Development and Environment at the University of Bern in Switzerland. And today we will have a presentation by one of our working group members, Dr. Martin Bruckner from Vienna University. And he will present on the FABIO input-output model. And you're all invited to ask questions in writing. You can do so through the questions box. You will be muted throughout the webinar, so you can't speak. But please put your questions whenever they come up, and then in the end of the presentation, I can ask them to Martin and we will have a discussion. The webinar recording and the slides will also be uploaded on the GLP website, probably today still after the webinar. And I will also share the link to the working group participants via email. I think with that, we are ready to start. And I would like to invite Martin to start with his presentation. Thanks.
Thanks a lot, Julie. And thank you for the opportunity to give this webinar. A very warm welcome also from my side. I'm really glad that I can present today the food and agriculture biomass input-output database to all of you. So what can you expect from this webinar? First, I will start with what is FABIO, then how can it be used by each one of you. Then I will show you some current applications that we are working on and give an outlook on further research that will come later. Okay, so let's start with an introduction. What is an input-output table? FABIO is a set of physical multi-regional input-output tables. And what you can see here is an exemplary input-output table. FABIO comprises 191 countries plus rest of world. And 130 commodities. So this input-output table shows let's look at a column. Let's say one at the cattle column of Germany would show the inputs. For example, the soybean inputs and the wheat inputs and the inputs that are required, and from which countries these inputs come from. So that's what the input-output table shows us. These FABIO comprises time series of input-output tables starting from 1986 to 2013. Then, as I said, it covers 130 commodities. 127 of them are agricultural commodities, 64 crops, 32 processed products, mainly vegetable oils and cakes and sugars and beverages, then 14 animal groups and 17 livestock products such as different kinds of meat, milk, hides, and fats. And it currently covers 3 forestry commodities. It also covers environmental extensions. At the moment, the database includes data for harvested area in hectares, harvested biomass in tons, and blue and green water in million cubic meters. The data sources that we use to build this database mainly FAO stat. And from FAO stat, we sourced many different data sets, but the most important ones are the commodity balances and the bilateral trade data. For biofuels production, data from the International Energy Agency and from the Information Administration. Then for biofuels trade, we used UN Comtrade and BAKI. Feed use, we built feed feed balances for all countries worldwide based on data from the image model from the publication of Baumann et al. 2013, and water data we sourced from Mekonnen and Höxtra. Okay, then actually the starting point for this database of output tables was to build supply and tables in physical units. So here you can see a little example for a few commodities: soybeans, soybean oil and cake, cattle and beef, and how such a supply and table can look like. You see that soybeans are supplied by the process called soybean production. Soybean oil extraction, the process of soybean oil extraction supplies soybean oil and soybean cake. Cattle husbandry supplies cattle, while cattle slaughtering supplies beef. So that's the supply table. And then we have the use table showing where these amounts of commodities that are supplied are then later used. So soybeans are used in this example as a seed for soybean production, as an input into soybean oil extraction. Then oil is going to demand. At the very right side of the use table, you see food use, change, and other uses. So these 20 units, let's say tons, 20 tons of soybean oil are used in this example for food and for other uses, which is, for example, in the chemical industry or as a feedstock for biofuel production. Then soybean cake is going into cattle husbandry, cattle is going into slaughtering, and beef is used by final demand for food. So that's how the supply tables look like. The full multi-regional supply and use tables for all 192 regions and 130 commodities will also be available online together with articles. Now on the next, I'd like to show how supply and use tables are converted into symmetric input-output tables. And here is an example. You can see that now we have a table with products by products. Before we had products in the rows and processes in the columns. Now we have products both in rows and columns, and we see soybeans, 5 tons of soybeans going into soybean, 80 tons going into soybean oil, 80 tons into soybean cake. Then soybean cake, these 80 tons of soybeans that go into soybean cake, you can find them again in the soybean cake row, and the cattle column, 80 tons of soybean cake going into cattle. Then 30 units of cattle, actually livestock is in 1,000 heads. So, this, let's say, heads, 30 units of cattle go into beef production. So this input-output table is using mass allocation. That means that the soybean input into soybean oil extraction is split among soybean oil and soybean cake according to their mass. FABIO also provides input-output tables based on value allocation, which is shown now below. So here you see that the split of soybeans between soybean oil and cake now is not 20 to 80, but 33 to 67. So the value of soybean oil is higher than the value of soybean cake. No, sorry, the price. It's the price of soybean oil is higher than the price of soybean cake, and that's why value allocation, a little bit more of the soybeans are allocated to the soybean oil than before. It was 20%, now it's 1/3. And then there would be additional options such as energy allocation, currently not implemented, but can be easily implemented, which would then give again a different allocation. Like in this example, soybeans would be distributed 40% to soybean oil and 60% to soybean cake. But yeah, the FABIO database currently comprises multi-regional input-output tables using mass allocation and using value allocation. We will see examples later where you can see how this affects the results. Okay, then, yeah, I already mentioned that there are the final demand categories of food use and other uses. Actually, other uses, that's not really a final demand, but in FAO stats, it is considered the final demand. But actually it's used, this is in this example, 10 tons of soybean oil going into other uses that would, for example, go into the chemical industry and would be further processed and would go into potentially international product supply chains. So it does not end at this place of industrial use. And that's why we link FABIO with the monetary MRAO database, EXIOBase, where so this gives a hybrid multi-regional input-output table with FABIO in the upper left quadrant, EXIOBase in the right quadrant, and in the upper right quadrant we have the inputs of agricultural commodities into non-food industries of EXIOBase. In total, this hybrid IO table has roughly 35,000 rows and columns. So that's quite massive. Then on the next slide, you can see a comparison of different available MRAO databases. And here you see that, yeah, FABIO is among those with the highest country detail, with 191 countries plus rest of world. Then it's the one with the highest detail also for agriculture and food products, and also for forestry products. Although 3 products is not much yet, we will increase the detail for forestry products later. And then, of course, FABIO does not capture any other products or services, which are, of course, captured by all the other MRAO tables. But when combining FABIO with EXIOBase, we actually can cover 172 non-food industries and services. It's in tons. FABIO is in tons and heads. Heads for livestock, as I mentioned, and it's quite a long time series, which will also be extended in the future. Okay. Now, how you can use FABIO? First, what you can do is you can go on GitHub. I've provided you some links here where you can find all the R codes that we used to build FABIO, to build the hybrid FABIO Exio-based model, and then also there is a repository with called FABIO PA, which gives the codes for the structural path analysis that we did to analyze international supply chains of agricultural commodities. And then we have another repository with IO visualizations, which I will also show you later. Then the whole database will be published on Zenodo. Here's the link, which is currently not online. So we have to still to do some checks, and we'll then publish the whole database under the GPL license on Zenodo. The FABIO paper is already available online. It was published in Environmental Science and Technology, and you can also look at fabio.fineprint.global to get some further information. Okay. Yeah. Now I would like to show you our online visualizations. For this purpose, I switched to my browser. So I hope you can all see my browser now with this Senki for Indonesian oil palm. This tool is still under construction, but it will be available on fabio.fineprint.global. And you can simply select a country. You see here the list of all 91 countries and rest of world, and then also you can select a continent. So let's pick Asia Pacific, and here 130 products, first primary crops, then crop products, non-food alcohol here. You can see the full list here. There are the wood products, the industrial roundwood, coniferous, and fuel. These are the only 3 wood products that are covered. Here you can see animal products, pig meat, pork meat, pet food, edible offal, milk. Then let's select hides and skins from Mexico. So then here you can also choose a year. It's still under construction, as I mentioned, and we will upload the whole time series from 1986 to 2013. Then you select mass or value allocation. Then the environmental indicator that you show, which is the land use embodied in the supply, or the primary biomass, or the product unit. So the difference between biomass and product unit is, for example, in we have selected now hides and skins. The product unit would be the tons of hides and skins. Biomass would give you actually the biomass that is embodied in in those hides and skins, which is the feed for animals. So now we can see the Sankey diagram here, and you see that hides and skins from Mexico are mainly processed in Mexico itself, and only some smaller quantities are traded. They are processed mainly into leather products, which are also consumed domestically, but then also exported into the United States. Yeah. Then you can also change the detail that is shown. So we have a cutoff, we have defined a cutoff value, which here is 4%, where you can reduce that to show more detail and also show more regions. Otherwise, regions that do not receive a lot would be cut off, not to get too messy. So maybe this tool is to be used for teaching purposes or just to play around. Then I go back to the slides. Yeah, now I'd like to show you some of our current applications. We are working on an analysis of international cotton supply chains and the embodied water stress. You see that, which was surprising for us, only 1/3 of the cotton harvest is cotton lint and 2/3 are the cotton seed. Cotton seed is used as an animal feed mainly. You can see most of it is converted into cottonseed oil and cake, and the cake is then as a feed for cattle, poultry, pigs, and so on. But also the seed itself is used as a feed. And 1/3, as I mentioned, is the cotton lint, or it's 35% of the total harvest, which then goes mainly into the textile sector. It's used to produce wearing apparel, it's used to produce furniture, and so on. This Sankey is made using the FABIO version with mass allocation. Now, if we switch to value allocation, you can see that now it turns upside down. So now it's 2/3 going into non-food uses, into textiles mainly, and only 1/3 going into food and feed. This is because the cotton, although being only 1/3 of the harvested quantity, it's 2/3 of the value. And the seed has a much lower price than the lint, makes only 1/3 of the value. So in this case, 2/3 of the water stress would be allocated to textiles and other non-food uses of cotton. Yeah, here you see how it changes from mass allocation to value allocation, where in mass allocation a little bit less than half is going into food and another half into food, and for value allocation it's more than 2/3 going into non-food. Okay, another application that we are working on is food waste and diets. Master student Elena Foucroy was doing her thesis on the footprint of French food wastage, And in the left upper corner, you can see a figure showing the cropland wastage along the food supply chain at different stages of the food supply chain, starting with harvest, then storage and transport, then processing, distribution, and final consumption. We compared waste shares given by FAO in an FAO report on food waste with waste shares found in the literature specifically for France. So that's why you see here these differences for the yellow and the orange bars. Then, yeah, you can see that the largest part of the cropland is lost at the consumption stage and at the harvest stage. But that depends a lot where the products come from. In Europe, the losses at the harvest stage are much smaller, for example, than in Africa. On the right-hand side, you see this pie chart showing the source of the cropland in French food waste. Most of it is from Europe, but then there are 31 square meters wasted by each person in France coming from Latin America, and also 31 meters coming from South and Southeast Asia, and so on. In this study, we include not only cropland, but also green and blue water, or which you see below in this colorful bar chart. And here you see, for example, that fruits, although they only a share of 6% in the total wastage, they have a share of 15% in the total blue water losses. While cereals, have a very high share, relatively high share in the losses of cropland. Okay, one final slide showing an application that we are working on here, as also on food waste and combined with diets for Germany. Hannah Helander is doing her PhD in Freiburg, and she is showing here on this figure that what would happen if Germany would switch status quo to the recommended diet. And you can see that the biomass footprint would decrease, but actually the food waste, the quantity of food waste would increase. That's because the waste shares are higher, for example, for fruits and vegetables than for meat and milk. So the amount of waste would increase, but its footprint would be reduced still. Okay, then one final slide on further work that we are currently doing. We are now revising and polishing the codes, and we will make all data available, as I mentioned, still this year in the coming months. We will also do a nowcasting of FABIO for the years 2014 until 2016, maybe if possible until 2017. This will all be made available later on, and then we are also working on an environmental extension for greenhouse gas emissions, also for fertilizer use, nutrient input, and energy use. Then we will continue going subnational. We want to capture subnational commodity flows, we will start with Brazil and particularly with Mato Grosso next year, and add more countries and regions later on. And we will add more wood and paper products. So that's it. Here's again the link where you can find more information about the FABIO database. And if you have any questions or queries, please just send me an email. Thanks a lot.
Thank you, Martin, for this really fascinating insight on the FABIO model. I don't see any questions yet from the audience, so please, if you have any questions or feedback to Martin, just type into the questions box. Otherwise, I can start with the first question from my side, because I think these results, they are potentially very interesting for different non-academic stakeholders. So do you think these people, they can use the model as it is by themselves, or how do you envisage like working together with different non-academic stakeholders to make this useful?
So I think that for non-academic users, especially, the online tool will be useful, where people can play around, can find out the results for all different products and countries, whatever they are interested in. Of course, everyone is also invited to download the database and do calculations on their own. But I think that probably most non-academic users will rather rely on the interactive visualizations that we provide online.
Okay, thanks a lot. Now we have a number of questions from the audience. So the first one from Finn would be, when do you expect the link on Zenodo to be published, and whether the FABIO hybrid will also be provided with the publication of the paper on the dataset?
Ah, that's a good question. Yeah. Actually, so the FABIO paper, the purely presenting the purely physical MRIO, was published now. So we just need to do some final checks, and then the database will go online. Hopefully that can happen in the next 2 to 6 weeks. That's the plan, but that's only for the physical MRIO. The hybrid MRIO, there we will not publish the MRIO tables, but we publish the codes that can be used together with the FABIO database and the XIO base to build the hybrid tables. And actually, this code is already available on GitHub. So once FABIO is online on Zenodo, everyone can build the hybrid model.
Okay. The next question would be from Joachim, and he's asking whether it will be possible to use the tables as models to perform multiplier type analysis.
Yeah, definitely. Yeah. So we will also provide the Leontief inverse online on Zenodo. So you can simply take the Leontief inverse and multiply with the environmental extension that you are interested in, and use it then for multiplier analysis.
Okay. The next one from Nicholas is about, for which applications do you recommend mass allocation or value allocation?
Yeah, I personally for the attribution of responsibility, I personally prefer value allocation, because I think that, for example, in the cotton case, if we would not buy the textiles, nobody would produce the cotton. So the lower value byproduct, which is the seeds, which are used for feed purposes, in my opinion, should not receive the full responsibility, or the 2/3 of responsibility as it would receive when using mass allocation. But if you want to study global physical flows of commodities or of embodied energy or nutrients or so, then you should use mass allocation, because that's the actual mass flows which you get then.
Okay, the next one from Claudia is asking about whether the subnational version would be done in collaboration with the trace database, because she says these two databases could be perfectly combined to have a more complete view of the supply chain. Have you thought about this?
Absolutely, I would love to collaborate, and yeah, I'm in contact with some people from SEI, and yeah, I hope that we can work together in the future.
Then we have a question from Sebastian. Can the model show the difference between mass and value allocation in the flows between countries? For example, countries exporting lots of mass but getting little value.
Yes, in principle that's possible. Yeah, you can't see it in the online visualization, but if you download the database, then you can derive these numbers.
Okay. Then we have a question from Mikalis on with regards to the uncertainty and whether FABIO users will have any capacity to carry out sensitivity analysis besides the comparison of physical versus monetary allocation.
Yeah, that's also a very good question. We haven't done uncertainty analysis yet, and we have not come up with any quantitative measures. There are some parts of FABIO which are more uncertain than others. In our paper, we describe a little bit which uncertainties or which parts, for which parts we would expect higher uncertainties. Mainly that's animal products, I would say, and but not so much for the others, which are directly taken from FAO stats. Of course, there is also uncertainty in the FAO data. The commodity balances also, yeah, might also be wrong sometimes. But we will have to do carefully some uncertainty analysis, and yeah, we want to give the users some more yeah, information about uncertainties later.
Okay, thanks. For the moment, I don't see any more questions, but let's give it a little bit more time maybe. And I would also be curious to know, I assume that FABIO, or the construction of this model, was part of a funded project that you had. So what is the future of this? Are you confident that you will be able to further update and keep this model alive in the future? Or yeah, how do you see this?
Yeah, so actually the construction of FABIO was done in several projects. So
Okay.
we joined the forces of several fundings and for being able to construct FABIO. At the moment, we have the funding to continue, and I'm confident that we can keep maintaining FABIO and updating it, especially because with the R codes, it's rather simple. If there are new data published on FAO-Stat, we just run the R codes again, and we should have the additional year, for example. So if the data for 2014 is published, a few days later we could have the FABIO data set for 2014 available.
Okay, that sounds great. Thanks a lot. So I don't see any more questions from the audience. So I think in that case we will end the webinar. I also want to show you, in case you're not yet a member of our working group, how you can become a member. I will share the screen for that. One second. I hope you can see the PowerPoint slide. Can you see it, Martin?
Yes, I can see.
Okay, there you have the information. So the working group is co-led by Cecilie Friis and myself. If you have any interest to become a member, just click on the link that I've provided or go directly onto the GLP Earth website. And we are also looking for future speakers for our webinars. So if you have a topic that you would like to discuss about, then just drop us an email and we will try to arrange a date and time for a future webinar. And with that, I would really like to thank you, Martin, again for being the speaker in our very first webinar. And yeah, I'm looking forward to exchanging more with all the telecoupling people. Thanks so much to everyone.
Thank you. Thanks for the opportunity.
Thanks. Bye-bye.
Bye.